Hey there, folks. It should be Wednesday, the 28th of October. So we're getting real close to the end of this month. In fact, next time I see you, it should be November. Um, and so we are looking at chapter 16 today. Chapter 16 is about um, mass movements of material. It's a very interesting chapter because these are sort of natural disasters that happen. We've talked about earthquakes and volcanoes and all kinds of things. So these are, again, natural disasters that can happen. They don't happen very often. We don't see them a huge number of times here in the United States, although there are places where it's quite it can be very common. So here in Kentucky, we don't get much of that. So I'm going to kind of go through it fairly quickly, but I definitely want you to read it just so you're familiar with it. There won't be a excuse me. There won't be a ton of stuff about it on the test, but you need to understand kind of what's going on generally. You don't have to get into all the details, but I'll kind of go through that with you and help you figure out what's important and what's not so important. So let's go ahead and jump right into to chapter 16 here. And it starts out with a story about a landslide that happens in Peru. There you can see the village and the mountain in the background, and then there's a terrible landslide, and the village is completely buried. So these kinds of things can happen. This one's quite a you know excessive. Most of them are much smaller, but this is a big one, and quite a few people were killed. So it is a natural disaster. It is something we need to be aware of. Like earthquakes and stuff, they're kind of hard to predict when they will happen. Sometimes you get a little bit of a warning. You might see cracks. You might see small debris beginning to fall, but you really don't get much warning. So it's important to understand how these work. So the movement itself is called mass movement. And we're going to look at some of the types of mass movement. Of course, landslides are one, and landslides can have lots of characteristics. They can be mudslides, they can be rock slides, that sort of thing. And we'll differentiate those in a minute. Or they can be avalanches, and we've all heard of or seen pictures of avalanches where it happens a lot of times in ski areas. Someone's skiing in a backcountry, and you can release an avalanche. We'll talk a little bit more about how they work. Your book goes into a little bit more detail, something called rock glaciers, which are kind of like glaciers of ice, although there's more rock than ice, and they can move only at a very slow pace. Your book talks about something called creep. So some of these happen very slowly, almost in slow motion. You don't even see them taking place. Um, Things like creep and sulfication happen very slowly. And here's an example of creep where the soil freezes, and of course, when water freezes, it expands, and so that expands the soil. You may have experienced this sometimes if you've ever walked out on a lawn after a deep freeze, and you kind of feel the ground kind of crunching beneath you. Well, that's the water that's frozen and rose up. Sometimes this can happen with the soil. The whole thing kind of rises with the water, but then when it thaws, it comes back down. If it's on a slope, it doesn't come back down in exactly the same place. It comes down the slope a little bit. And so after a few years, you can get a slump. And here you can see where trees have been slumped, and you might see telephone poles on a hill that are kind of sideways. And this is caused by slump. And again, it's a very slow process. It can take years, but it is a kind of mass movement that can move quite a bit of material in a short period of time. Here are some more slumps, some scarps that they talk about where a section of the hill has gone away. And a lot of times this is caused by water. We'll see that water causes quite a bit of this simply because water acts as a lubricant. And so if you've got an area that's already kind of unstable and you get some water in there, especially a lot of water, you can break a big chunk of this off. And something that maybe didn't fall before will fall now. Here's a good example of some of these, where we have what we call mud flows, debris flows, and lahars. They're all associated with water, where been a lot of rain or something's happened and the ground gets saturated with water. Once the ground is saturated, Like I said, any weak areas tend to break loose, and then of course the weight of the rock on top of the weight of all that water um, creates a pretty devastating, or can create a pretty devastating fall. The lahars, of course, we've talked a little bit about. They're caused by volcanoes, so you can imagine a volcano that is maybe dormant, has snow on it, and suddenly begins to erupt. All that heat melts all that snow, and so you've got an enormous amount of water mixed with ash, and it's essentially concrete. it's it's natural concrete, and so this stuff can flow down. Um, I was looking for a picture. We'll probably run into it here in a minute. But it can flow down and cover things up. And then the bad thing, of course, about what that is that it will begin to hydrate and dry and literally turn into concrete. So anything that's stuck in it has to be literally chiseled out, not like a mud flow where once it dries, you can sort of pull things out of the mud. But yeah, here we can see one of these lahars where here's the volcano with, you can still see the snow on it. When it erupted, all that snow melted, all that water mixed with the ash, and it comes flowing down and can bury cities and peoples and towns and roads and just all kinds of things. So it's a pretty nasty thing if you live near a volcano. Rock slides and debris slides. Again, we talked about most of this happens with water. These are a couple that usually don't happen with water. At least a rock slide can happen because of weathering, where rocks are being kind of broken apart. And there's cracks and they're already kind of loose, and then something can happen. Other rocks can fall down and hit it, and then the whole thing kind of makes like a you know. Chain reaction where one hits another and the whole thing comes down. So they can be pretty devastating. Of course, they can also be caused by earthquakes. So you may have loose rock and stuff on a hill or a mountain and have an earthquake, and then the shaking can loosen the rocks and bring them down, and that happens quite often. Avalanches, of course, we've talked about. They happen a lot of times. We think of avalanches with snow, and snow is a deposition, only it's a deposition of frozen water instead of sediment. And so the snow can come in various forms. Sometimes you may have a dry snow, sometimes you may have a wet snow, and then they can layer up. And if you cut through the snow after, especially someplace where it snows quite a bit, when you cut through the snow, you can actually see the layers, just like if you cut through rock to build a highway, you can see all the layers. You can see the layers in the snow. And we've learned that certain layers, if you have a wet snow and then a dry snow on top of it, the weight of that and then the wet snow melting, again, the water begins to act sort of like a lubricant, and that's where a lot of your avalanches come from. And so again, we don't have too much problem with that here. Places like Switzerland and maybe out west where some of the ski slopes and stuff are, they do have quite a bit of problems with that. There you can see some of the avalanches, and again, some of them could be quite deadly. If you are a skier, you've probably learned, and if you do go backcountry skiing, you've probably learned how to get out of an avalanche. They say you actually swim. So if you're caught in an avalanche, you start swimming like you're swimming in the ocean, and you literally, as that snow is moving, you swim up to the top of it. Because what happens when the avalanche stops, that snow all packs, and so people literally get frozen into the snow. And if you're frozen in the snow where you can't breathe, that's how people can literally get buried alive by an avalanche. Your book talks about submarine mass movements. Again, this is things that happen under the ocean. Some of these mass movements that start out above the ocean and then go into the ocean can cause tsunamis. So we have seen some of that activity, but the ones that start inside the ocean or under the water generally don't displace water. They just simply move from one place to the other. And we can see activity like this. And again, these are caused by volcanoes, volcanic activity. It could be earthquakes, that sort of thing, can cause these kinds of mass movements. But because a lot of us don't live under the ocean, it's not a huge issue. So why do they occur? Again, you need gravity. So if you live in a field, a perfectly flat field, I would say you wouldn't have to worry too much about these sorts of problems. But if you do live near a hill or live near a mountain or live at the bottom of a mountain or live in a valley or something like that, then yeah, you'd want to know kind of what causes these. And we've already talked about a few issues, the biggest, of course, being water. So if you lived in an area where things were fairly dry and then all of a sudden you get a lot of water, that could be a problem. Now, plants have a tendency to hold soil together. So if you've got trees and plants growing, that's usually a good sign. But you can imagine out west where they're having forest fires, after the forest fires have happened, now they're having problems with mudslides and rock slides. And because the trees are now gone, the vegetation is gone, and now it's going to rain. And so that rain, instead of being soaked up by the plants, now is soaked up by the ground. And so places where they've never had rock slides or mudslides, now they're getting them because of the forest fires. So it is kind of a double whammy where you live in an area and the trees all burn down. And then once that happens, now the ground is unstable. And so that can be a real problem. Earthquakes, again, we've talked about. Earthquakes associated with volcanoes can obviously do this. Your book talks about slope stability. And we're going to talk about something called the angle of repose. So if the ground got pushed up by tectonic activity, it could change this angle. If you just took some sand and started dropping it and made like a pile of sand, it's gonna stay at a particular angle, and that's what we call the angle of repose. And different sands, different materials have different angles of repose. Once you exceed that, then you run the risk of having a landslide or a mudslide. There we have two different kinds of sand, one with rounded edges so they don't stick together and they kind of flatten out, another one with sharper edges and they kind of hold together. And so this is what we talk about when we talk about the angles of repose. Neat pictures here about different ways this can happen. That could be in your notes, be a good thing. One thing that does happen during earthquakes too is something called liquefaction. And your book talks about how, especially with clay soils and backfilled soils, this happened in the San Francisco earthquake a while back. They had filled in a big area that had been water at one time, filled it in with backfill, and then built a bunch of houses on it. Well, when the earthquake hit, all that area liquefied, and the clay fell apart, and literally, the ground just turned to water, and these buildings all sunk down into this water. So this is also could be very dangerous thing, especially if you're living in one of those buildings near the earthquake zone. More details then about how this happens. Now, obviously, where these occur are places where we have hills and mountains, places where the ground is unstable, places where, again, you've maybe had forest fires and lost the vegetation that holds everything together. That could be a problem. California seems to get all the bad things. They've got the volcanoes and earthquakes and forest fires, and now they have mudslides too. So if you're planning on moving to California, you might want to take this course and change your mind. But anyway, yeah, there's areas there which have had problems in the past. I think a couple of years ago, or even last year, one of the famous highways, that Coast Highway, was blocked by several mudslides, and you had to drive around them, and you couldn't go along the ocean like you normally do. Can we protect from them? Is there anything we can do? Yeah, I mean, the main thing is don't live there. Don't live under a mountain. But if you do have to live under a mountain, it's good to know the circumstances. We can see where these mudslides have happened in the past. So if you live in an area and you see a lot of evidence of mudslides in the past, it's probably going to happen again. Keeping an eye on, again, plants. Plants can hold the ground together for the most part. And then if you have a fire or something happens to those plants, maybe construction or something happens, that can weaken the hillside. So you just have to kind of be aware of how this happens. And again, if it's like an earthquake or something, you can live there. But if something's going to happen, you definitely want to be ready to leave. Preventing mass movements, we talked about revegetation, regrading, so bringing something back to an angle of repose. Once the ground is at its angle of repose, it's not possible for it to have a problem. So that's another solution. reducing subsurface water. You might have to put in drains, that sort of thing, and preventing what we call undercutting, where the ground kind of cuts away at part of that, maybe a hillside or something. So these are all things we can do. It's not cheap, and then of course there's other kinds of ways. Here's an interesting one they do. Apparently, this is being done quite a bit in Switzerland. They build these avalanche sheds where you're driving under, and if there's an avalanche, it'll land on the shed and not on your car. So that's kind of amazing. But anyway, like I said, this is a kind of a quick chapter. Um, there may be a question or two in the final about it, but it's not a big major thing since we here in Kentucky don't have too many problems with this. Your questions are here on page 612, and there is just 5 of them. So if you decide to do this one, you got to do them all. Or excuse me, maybe there's more on the next page. Let's see. Yeah, there's a few more. So that's all there is. I'll see you next time.